All right, let's work on 2C. Welcome to Mr. Johnson's notes. Solve an absolute value equations in two variables graphically. I erased out the algebraically. We did that on 2A and 2B, or 2A. Example 1 here, we need to graph this. So this is really just very similar to Unit 1. I'm going to highlight how to graph dilations a little bit more. So that's what I'm going to do here. And then we're going to name 3 solutions. So we're going to be able to pick out 3 solutions for this graph. So the steps to graph. First I would do, find the location, find the vertexes location first. So how we do that, let's think back to Unit 1. The vertex started at 0, 0. I just did a quick graph. There's other points. That's a terrible looking graph, but all I care about is the vertex at 0, 0. How do we go where that vertex is going to be? Well, you look at left, right, and up and down. So left and right. So plus 4, what does that mean? That means left 4. And then minus 5 means, oh my goodness, down 5. So the vertex, well, left 4, 1, 2, 3, 4, down 5. Here we go. There's the vertex. So now the next thing we're going to do is we're going to look at the dilation. So second, the dilation, the scale factor. We would look at it as rise over run. From Algebra 1 as a slope. And this means rise means up or down. And run means left or right. So we have from the vertex now, we're going to go, we got to make it a fraction because it's looks like a fraction. So 2 is the same thing as 2 over 1, 4 over 2. You can make it any kind of fraction equivalent to 2. But from our vertex, we're going to go up 2 and right 1. You can also go, so absolute value functions are mirror image to the left and right side of absolute values. So we can also go up 2 and left 1. You can keep going with that pattern, up 2, left 1, up 2, left 1. From our point on the right, up 2, right 1, up 2, right 1, and then draw our graph. Draw the V. Third, draw the V. All right, next we need to name 3 solutions. So 3 solutions. Well, let's pick out any coordinates. Really anywhere along the absolute value line, the graph is anywhere along the V. You can stop anywhere. It doesn't have to be integer coordinates, but you can stop anywhere and that would be a solution. I'm going to actually pick out the integer coordinates here. So let's see, we got -2, -1. That's one of them. Let's go with the vertex because that was easy. -4, -5. And let's estimate one. So somewhere along, let's go with, there's a point, anywhere along the line is an infinite amount of points put together, coordinates. So let's see where would that one be that I just drew? Ooh. So that's somewhere around -6 point. So I'm looking at this point right here, -6.4. I'm estimating 0. We don't really know that point unless we substitute 0 in for the y. So you could substitute 0 in and solve this equation. And then you would actually find what that point is. But I'm just looking at the graph. So there's 3 solutions. Example 2, find the function for the given graph. All right, so first thing we're going to do, and the reason why I'm doing it again is now we have to actually, we're going backwards. We're going opposite. So we have find the vertex, -4, -1. So that's left from 0, 0. It's left 1, 2, 3, 4. So left 4. What does that mean when it comes to the equation? It means you go plus 4. So plus x plus 4. Then we go down 1. What does that mean on the equation? It means on the outside of the absolute values, you're going to put a minus 1. Now the next part is to find the next coordinates. So the next coordinate, as I'm sliding down the graph, looks like the next easy coordinate, the coordinate that would be integer values, either on the right side or left side, would be right here. -1, -2. Oh my goodness, -2. All right, so what you're going to do is just go with rise over run. So we don't actually need those coordinates. I just put them on there. But we're going to go rise over run. So we're going to go down 1. So down 1 and left 1, 2, 3. So, or down 1 and right 1, 2, 3. So left and right don't do anything with negatives. It's just down 1 is a negative and right 3. So -1/3. So we could rewrite this -1/3 absolute value of x plus 4 minus 1. So with left and right, don't worry about positives and negatives. It's just left or right. That's going to be just always positive. And we look, it's a negative. So you look at the graph, it's upside down. So that means there's a reflection. So that's good. There's a negative. There has to be a negative in the equation. And then it's 1/3, down 1, right 3, or down 1, left 3. Perfect. All right. Let's move on to the next. So 2D is graphing. Graph the inequality and give a solution. All right. So first thing we need to do, it's the same thing as the last page. Do your left, right, up and down first. So that means left 1. So from the vertex, 0, 0, we're going to go left 1. So let me erase the... So left 1. And then the next step is draw the next coordinates. With the dilation. So we have 3, let's represent that as a fraction, 3 over 1, so it's rise over run, so we go up 3, right 1, or you can go up 3, left 1. We can continue that pattern forever. The next, we're not going to draw a solid line, meaning because we have inequalities now. Inequalities doesn't automatically mean solid line. The only way you can represent an inequality on a graph and tell the difference between like a less than or equal to is by drawing a dashed or solid line. If it is a less than or greater than, so no equal to, it's a dashed line or a dotted line. If it's less than or equal to or greater than or equal to, so it's all about the equal to, that is a solid line. Think back to the last graph, or last page, these are equal to, so it's a solid line. So now we're back here, back to this graph. Well, let's look here. It is not an equal, it is a less than, is not equal to, so we're going to draw this as a dashed line. And I always draw it off the graph because we have to think about it that this inequality, they go off the graph, just what you're seeing. The next thing is we need to shade. So shading. If it is less than or equal to, shade below the graph or underneath it. If it's greater than or equal to, shade above the graph. So what do we have here? We have a less than symbol. So that means we shade what's below it. It's on the outside of the V is below the line. So we're going to shade on the outside or below the graph. So there we go. And now we got to give a solution. So a solution is anywhere in the shaded area, and because it's a dashed line means it's not equal to that. So the graph, we cannot pick a point on the dashed line. So pick a point anywhere you want. Let's see here. I'm going to go far away from the line. 6, what is that? 6, -5. So solution, 6, -5. Anywhere in the shaded area means those are all solutions. Anywhere, even really super close to the dash line, but it can't be on the dash line because the dash line means it's not equal to it there. All right, example 2, give the inequality for the given graph. All right, so let's see. First we find the vertex, -3, -2, so left 3 from 0, 0, and down 2. So left 3, down 2. So left 3, what does that mean on the graph? A lot of lefts here. Left 3 means +3. And down 2, what does that mean? On the outside, it means subtract 2. Now, let's look at the slope, or the scale factor. So let's find along the graph where our next coordinate is. Doesn't matter left or right, you could go. And what would that be? Rise over run. You go down 2. So down 2. And then left or right, and that's always a positive 1. So -2/1, that's the same thing as -2. So we're just going to put a -2 right next to the absolute value. And then this next blank is the inequality. So what inequality is it? Well, it's a solid line. I see it's a solid line here. So that means it's equal to. So I know there's going to be equal to underneath. And then which way is it shaded? Well, it's shaded below the graph or underneath the graph. So that's less than. So it's a less than or equal to because it's a solid line, less than because it's shaded below. All right, come to class with any